All right, this video is to demonstrate how to use the law of sines to find a missing side and a missing angle in a non-right triangle. So far, we've used right triangle trigonometry to find missing sides and missing angles in right triangles. So here we're going to take a specific look on non-right triangles. And so what we developed in class is that given a non-right triangle, such as the one on the left, triangle ABC, the law of sines is going to give us proportions that allow us to find those missing sides and missing angles. And again, like we did in class, the law of sines, what it gives us is a proportion between an angle, the sine of an angle, and its opposite side. So as you can see, as I have it written out here, we can write the sine of angle A divided by side A. The sine is equal to the sine of angle B divided by side B, which is also equal to the sine of angle C divided by side C. Now, alternatively, some information will show this reverse. It'll put the sides in the numerators and the sines of the angles in the denominators. That is totally okay. It is still proportional, and everything will work. Now, as we're solving problems with law of sines, we're not going to use all three ratios. We'll use two of them, and that'll create a proportion for us. And that's how we're going to solve. So let's take a look at number one. Let's zoom in on that. Let's take a look at number one. So we are asked to use the law of sines to set a proportion and solve for x. So what I'm going to do here is I always like to highlight which side and angle are opposite of one another. So here, for instance, the side labeled with a length of 12 is opposite of the 35 degrees, and the side labeled x is opposite of the 71 degrees. This helps me write my equation using the law of sines. So for my equation, what I would write here is I'm going to start with the 35 degrees. So I'm going to say sine of 35. And we understand it to be in degrees because when we get to our calculator or whatever we're using, our technology, we got to make sure it's set in degree mode. So sine of 35 degrees divided by 12 is going to be equal to the sine of 71 degrees divided by x. And so now we have a proportion. And so here we're just going to cross multiply because that's how we solve proportions. And that's going to leave us with x times the sine of 35 degrees will be equal to 12 times the sine of 71 degrees. Now what I need to do is isolate x, and right now x is being multiplied by sine of 35. So we're going to divide both sides by the sine of 35 degrees, and that would give us x is equal to 12 times the sine of 71 degrees divided by the sine of 35 degrees. And now what I would do is I would go to whatever technology I want to use. I like to use Desmos for something like this. But remember, the thing we have to remember if for Desmos or even on a calculator, we got to make sure to set it in degree mode. So again, in Desmos, you click on the wrench, click on the degree button at the bottom, and now Desmos is set to degrees. So I need to evaluate what x is. So when I end up with a statement like this that has no variables, it means I need to evaluate. So I'm going to take 12 times the sine of 71 degrees divided by the sine of 35 degrees. And I just want to double check that I've got the angles in the right place. I do. And so if we're rounding to the nearest tenth, I have 19.78. The 8 would round the 7 up to an 8. And so we would come back here and say that this missing side, x, is approximately 19.8. And it'd be units because they don't tell us a measurement here, right? 19.8. And that would be our answer for this one. Now, sometimes if we go to number 4 from the handout today, sometimes they're not going to give us all of the information we need, but we can still use the law of sines to find the missing side. And what I mean by they're not going to give us all the information we need, if we look, we've got the side labeled 27 and it's opposite of the 96 degrees. However, when I look at the side labeled x, what I'm going to see is that it is opposite of an unknown angle. They don't give us what this angle should be down here. Now, because we're given a triangle with two angles already labeled, I do know, however, that 180 has to be, or the angles in a triangle have to add up to be 180. So this missing angle down here, I'm going to call it 3 question marks, is going to be equal to 180 minus the sum of the two angles that I already know. Or you could just take 180 minus each of the angles, right? So I'm going to come back to Desmos. I want to know what 53 plus 96 is. So I'm going to do 53 plus 96, 53 plus 96. And then I'm going to subtract that from 180, so 149. So that tells me that missing angle that they're not telling us the value of is 31 degrees. So this one right here is 31 degrees. So I'm going to go ahead and note that. I'm going to put 31 degrees in here. That's going to be too big, so let's go here. 31 degrees. Okay, so that one is 31. And so now I have enough information to set up my law of sines. So we're going to do exactly that. And so I'm going to go ahead and write myself an equation for the law of sines. So what we have here is I'm going to start with what I know. So I'm going to start with the things highlighted in green. So I'm going to say sine of 96 degrees divided by 27. It's going to be equal to the sine of 31 degrees divided by x. Cross multiply because I have a proportion. So I'm going to have x times sine of 96 degrees is equal to 27 times the sine of 31 degrees. And so now I need to isolate x. So I'm going to divide both sides by sine of 96 degrees. So I'm going to have x is equal to 27 times sine of 31 degrees. And here I would have it's divided by sine of 96 degrees. And so now I'm ready to evaluate. I come back over to Desmos, and I'm going to take 27 times the sine of 31 degrees. That was our missing angle, sine of 31 degrees. And then we brought over sine of 96 degrees. And so here we get 13.98. If I'm rounding to the nearest tenth, this 8's going to round the 9 up to a 10. The 1 would carry over to the whole number, and then I'd have a 0 as my 10th place. So that means here x is going to be approximately 14. So I have x is approximately. And I would still say approximately because I am rounding, so I'd say 14.0 or just 14. And that would be our final answer for that one. That would be our final answer. And so that's how to find a missing side using the law of sines. Come back for the other video, and I'll show you how to find the missing angle using the law of sines in a non-right triangle.